Hey physicists, we're going to take a look at example 6. So this goes on the green sheet that you had yesterday, and it's just another problem. The more problems we do, the better we understand this force business. So in example 6, we've got Miss Piggy hanging a picture on the wall. Not a surprise if you know anything about Miss Piggy that maybe it's going to be a picture of her, as you see, okay? And to keep things simple for this problem, we're going to say that it's suspended from one string. So we're going to go ahead and draw a free body diagram. The picture is the dot, and we need to add the forces that are acting. So if you can imagine this thing hanging from a string, we've probably got the Earth, and the Earth is going to pull straight down, just like it always does. That's going to be the force of the Earth on the picture. That force of the Earth, as always, is going to be the force of gravity. Because we don't have a surface, it's not sitting on something, there is no normal force. And that's something that I really want to make sure that you understand, is that if there's no surface, there's no normal force. So unlike the frog sitting on the table or the bowling ball sitting on the floor or whatever it was, no normal force exists because there's no surface. Instead, it says that the picture is being held by a string. So that string is pulling straight up in this case. So we're going to add another force going straight up, and this is going to be the force of the string on the picture. We're adding yet again another new type of force. A force of a string pulling or pulling up, pulling over, we'll do a few of those types of things, is called a tension force, F sub T. We'll define that in the next video, okay? So we're going to take a look at what's going on here to see what's happening. I always like to start with is the object accelerating in the Y direction? That's this one over here. So if we've got just a picture hanging suspended on a string, I'm hoping that the object is not accelerating, so we're going to say no. And if we take a look at the F net then to add up all the forces, because remember net just means add up all the forces, we've got the force of tension pulling up, and we've got the force of gravity pulling down, okay? It's not accelerating, which we know from our conversations before means that the net force has to equal 0. And to make this a nice complete picture, we're also going to say then that those two forces are equal, and we're going to mark them on our free body diagram to make sure that it is all documented in the picture. There is another question. It says, is the object accelerating in the Y direction? And I'm going to guess, again, if you have it suspended, that no, indeed, there are no forces acting in this is X direction, excuse me, in the X direction. And in this picture, in particular, no forces are acting in the X direction. So F net equals 0. That one is done. There you go.